Good morning. Welcome to episode number 3 of the ZOOMTOWN experiment. For today's episode, we're going to take a look at defining the Zoomie, aka the robotic car. As you can imagine, the Zoomie is going to be the star player of this video series. The Zoomie's objective is to follow the provided driving instructions and travel to the destination without crashing into another Zoomie or anything else. Every destination is in the form of a driveway. Therefore, their trip consists of the following: backing out of a driveway, drive on the roads based on the provided driving instructions towards the destination, drive straight on straight roads to avoid bumping into anything, make turns as needed, again, not bumping into anything, to avoid obstacles such as other moving Zoomies, and finally, park in the destination driveway. In order to accomplish that objective, the Zoomie has to be fairly self-sufficient and reliable. There are a lot of sensors that can be used to do this, but a major challenge within the ZOOMTOWN experiment is cost. For example, putting a vision system on each Zoomie is way out of the budget. There are other constraints and requirements that I've also identified. Autonomous is key. I really need the Zoomie to be able to get from start to destination on its own. It can be provided with information, but other than that, no intervention should be caused by outside sources. Size. It has to be small. Several Zoomies moving at the same time is going to be difficult enough, and if they're too big, it's just going to end up being a demolition derby. While fun to watch, I'd prefer we don't go down that path. Another factor of size, it has to be big enough to hold all of the required components, and that'll be a key word, required, as we get further into this project. Cost. Everything comes down to cost, doesn't it? We need to keep this experiment affordable. As I've mentioned in the previous videos, this is going to be a fairly expensive investment and project for this video series. I'm estimating it'll be between $1,000 and $2,000, and it can go up or down from there. Until we get into it fully, I won't really know. And funding from the advertising on my YouTube videos so far has only provided about $3 a video. So cost is a very important aspect to what I'm about to do. And so that leads us to the next item. This project will be primarily based around Pico microcontrollers. I've come to love them. I've done a lot of videos of them here on the channel, and people seem to really enjoy them as well. The other aspect, for the Pico W, here in the US, those sell for about $6. This will need to be battery powered. I can't have 15 to 16 Zoomies running around the track if they're all tethered to some power source. So battery power is important. I'm preferring a wheel drive over a track-driven type device. I believe the tracks have advantages. In this case, I think they would be greater complexity and perhaps even cause a lot of damage to the roadway surfaces by marring them up, etc. The Zoomies got to be maneuverable. They need to be able to make tight turns, such as pulling into and out of a driveway. They need to be reasonably fast with variable speed control. This isn't about a race. This is about going through the process of understanding autonomous transportation, getting from point A to point B without bumping into other Zoomies doing the exact same thing, probably at the exact same time. So speed is important, but not super high on my list. Further down, as we get into this experiment, we may want to swap out the motors and put in higher performance motors and make them go faster to see how fast we can push it, though. If you've watched the previous episode, you already know that line following will be very key to this whole experiment. Accurate directional control without line following. That's going to come into play at intersections. Again, referring back to the previous video, it should be pretty clear why line following can't be used throughout the whole process. There's another aspect of the Zoomie that I want, and that's for it to be able to sense road signs or markings. I'm not exactly sure how I want that to play into the experiment, but I think I need to have that ability. It needs to be able to sense objects in its path so that it doesn't bump into, at this time, another Zoomie or perhaps a barrier. It will need odometry so that it can measure its movement. That'll be really important in a lot of different situations in this experiment, leading up to and including basic localization of some sort. This Zoomie will need to figure out where it's at during its trip. We can't just rely on dead reckoning, as if you've done robotics before, you'll know that dead reckoning is okay in a general sense, but it's not going to work for very confined areas such as this experiment. The next requirement is not going to make much sense for a long time, but I needed to have a large flat top on the car or the Zoomie. That's going to be critical, I believe. Perhaps I'm wrong, but we'll see as we get further down the road. Simple visual feedback to us, the viewers watching the experiment, is kind of an important thing. Couple blinking LEDs can provide us feedback to the status, etc. Communication systems to get data. That seems like a weird requirement, but remember, the Zoomies need to get their driving instructions and destination information from the central computer which runs this whole experiment. And I'd like to incorporate a very basic type of failsafe to deal with code or sensor problems that may cause a lockup on the system. While that is a rough list of parameters and requirements, it does provide us with a direction to go in. Projects like this can easily get out of control, and we can go down way too many rabbit holes and not be able to get back out of them. So here are some other considerations that I find equally important. Feature bloat. That is a very real concern because I do get carried away with adding bells and whistles that aren't needed for the true objective. Any of us that have used software that's evolved over the last, say, 20 or 30 years, we all know them, we use them, they become very expensive. They can do anything, including cook soup for you. Reality is 90% of most features that are put into software aren't even used. So I don't want us to get into that situation with a lot of fun little gizmos and gadgets, but aren't true to the objective of the experiment. All they would do at that point is simply run up costs. Runtime, and that's in reference to the battery time. That's going to be a critical element because some of these experiments may last for hours. If we're running all 16 Zoomies or 15 Zoomies on the layout, that could go on, repeating a experiment run over and over again. So runtime is important. Having a minimal number of components greatly reduces cost and time savings as well as reduces complexity. From that, 3D printing is a great tool to help with that. I will be doing as much as I can with 3D printing as opposed to fabricating from basic components such as structural shapes, etc. I want to minimize a lot of or as much custom components as I can. Anytime you see the word custom, you know that's going to increase cost and time. And finally, for the electronic components, etc., I'm going to use modules as opposed to discrete electronic components. Yes, I can make things possibly more compact if I combine a lot of the circuitry all on a single PCB rather than modules, but again, the cost and complexity is going to go up dramatically. And that should give you a really good idea of all the technical requirements needed for the Zoomie, at least from the perspective of time right now. Once all the technical requirements are worked out, what is left is to create a style for the body of the Zoomie. As you may have noticed if you watched previous videos, I'm a car fanatic. I don't own all the cool cars anymore, but I've had plenty in my previous years. So I do like a nice looking car. And I've already spent many hours looking for a style for the Zoomie based on actual car designs. I have about 10,000 photos of cars that I have collected, and it is taking me a lot of time to look at them all. No doubt about it, the end result will be completely driven by the required mechanicals, or as they say, form follows function. But at least I can dream about coming up with a really cool body design, even if it isn't practical or in the reality for this project. For the next video, we're going to take a look at my first big old failure for this project. It was a little robotic car design that I had actually been pondering on for quite a while, so I finally sat down, put pencil to paper, created the design, went through, and did some testing on it. It was a failure for this experiment, but it was a great learning opportunity, and thus I want to include that in this series, because let's face it, part of the experimental process is to learn what we know and to learn what we don't know, learn what works and what doesn't work. And that was a good exercise for that one. With that, thanks for watching, and I hope you join us again next week for episode number 4.